that mechanics is a branch of physics that deals with the movement and interaction of various bodies. Mainly mechanics has two parts, classical and quantum. Classical or Newtonian mechanics is the study of motion of macroscopic objects and the forces acting on them, like gravitational force. Quantum mechanics is a subfield of physics that describes the behavior of particles such as photons, electrons at the molecular and the submolecular realm. But one important difference between the quantum and the classical rigid bodies is the concept of quantum entanglement. Now, what is quantum entanglement? In simple words, quantum entanglement is a phenomenon by which a pair of subatomic particles are allowed to exist in a mixed state or a shared state where they have complementary properties, such that by measuring the properties of one particle, one can automatically know about the properties of other particle. And this fact is true regardless of how far apart these particles are located. Now suddenly it comes to my mind that why I am discussing all this. Yes, there is a reason behind it. The Nobel Prize in Physics 2022 has been awarded to Alain Aspect, John F. Clauser and Anton Zeilinger for their experiment on this very research, that is the quantum entanglement, where they have experimented with the entangled photons, establishing the violation of Bell inequalities and contributing to the new technology of quantum teleportation, quantum computing and lots more. All these things sounding weird, right? Let's go back to the history then. In the late 1930s, Einstein was startled by the idea that the two entangled photons had quantum correlations. Now, if you are getting confused with the word entangled, let me help you out. When the two photons or electrons are entangled, it simply means that you have a tango and a ballet. Since these two are a type of dance forms only and they are somehow entangled in a way, means they are related in a way and they have originated from a single source, that is the dance. Now getting back to Einstein's experiment, let us try to understand it in a very simple way. Suppose we have a gamma ray. The gamma ray means the ray of photons and it is bombarded to a nucleus, resulting in the formation of an electron and a positron. Here electrons and positrons can be considered as two opposite particles originated from the photons. For example, if I consider a quantum property of these two particles like spin, if we measure the spin of the electron, say it comes to be spin up, then the positron is automatically in spin down state. Now let's suppose I place this electron here and positron say in the different part of the universe, somewhere in the universe, but very far apart from this electron. If we again measure this spin of this electron and it comes to be spin down, then automatically when we measure the spin of the positron at the same time, we'll get it to be spin up. It means that one particle knows about the spin of the other particle in no time and making a kind of system which has net zero spin. Einstein called this action as a spooky action. Spooky in a kind of ghostly action, as the particle which is situated here and the particle which is situated in some other part in the universe know about the properties of each other without having any connection between them. So Einstein made a prediction that there is something that is missing in the quantum world, and he said that there is something called hidden variables, that is a kind of predetermined information the particles have about each other but we are unable to make it. Or in simple words, he wanted to say that if the electron has spin up, this information the positron already has and it takes its spin down, and if this electron has spin down, then the positron automatically gets up in the spin up state, and as he knows that the electron now has spin down. Sounding a bit confusing? Okay, let us take a macroscopic example for it. Suppose we have an apple with us and it is red in color. And if we close our eyes, what can you say about the color of the apple? It still remains the same. The point being that if we are not measuring or noticing that physical quantity like spin of a quantum particle, then also it is existing and existing in the same state. And this is where the difference in the quantum and the classical physics begins. The classical world says if you are looking at the moon and it is there, then if you are not looking at the moon, it is still there. But the quantum world does not accept this statement. It says that the moment before you measure the spin of that electron, it is found in a mixed state of spin up and spin down. And the moment you measure it, its spin is defined. Now, John Stuart Bell, a scientist, worked on the Einstein ideas of hidden variables, and he wanted to make out that is it really true that the particles have predetermined states? So he came to a conclusion that if a particle is found to be in a particular state, that information is traveled faster than the speed of light to the other particle, and the particle knows the state of the first particle, which was against the special theory of relativity given by Einstein. So guys, finally, John F. Clauser has proved the Bell's idea to be completely violating quantum physics with a practical experiment implying that quantum mechanics cannot be replaced by a theory that uses hidden variables. Alain Aspect has developed the setup for this very experiment, and Anton Zeilinger has innovatively used the idea of entanglement both in research and applications such as quantum cryptography, quantum computing, and teleportation. And that's all for today. See you in the next video.